So you go on studying, you'll go on studying exceptions.
We are getting closer to the truth.
Exactly.
ये सत्य का ही पाथ में चल रहा है.
And you never know, a new theory will come up and say all these things are wrong.
Yeah. And so as you said, when Sir Newton stopped somewhere, वो बोला कि इसके आगे
तो भगवान,
उसके आगे भगवान
is written.
नहीं, लॉजिकली जैसा मैंने बोला, ऑक्सीजन एटम से तो बड़ा होना ही पड़ेगा, तभी तो वो सांस ले पाएगा.
हाँ, अगर उसको जिंदा रहना होगा,
सांस तो लेना पड़ेगा ना. जो भी जिंदा है, एवरीथिंग दैट इज सेंटिएंट.
अगर एक ऑक्सीजन का वो भी आपका उससे भी छोटा हो गया तो आप उसमें घुसेगा कैसे? हो सकता है. इन ए वे आई अप्रिशिएट योर इमेजिनेशन एंड ऑब्जर्वेशन. लेकिन आई डोंट थिंक कि एटम को इतना छोटा दिखाया गया है.
There is a void. Now this is in the atomic level. Now again, if I go subatomic level, the same principle will apply there. There will always be a gap. They will not be like this. Two matters won't be in contact with it. There will be a gap. So if there is always a gap, then this entire universe is a void. There's only gap. इसको क्या करेंगे सर? इसका क्या करना है? बस सिर्फ void रहने के लिए मैटर को होना जरूरी है, तो मैटर भी रहता है.
हाँ, तभी तो एग्जिस्टेंस होगा सर.
नहीं तो फिर सबको null and void हो जाएगा. तो दीप चला गया था. ये कप है ट्रुथ, सच्चाई. ठीक है, कैमरा में कप आ रहा है, तो दिस इज द ट्रुथ, दिस इज सच्चाई. आप उस लेंस से देख रहे हो, आप भी सच बोल रहे हो, मैं इस लेंस से देख रहा हूँ, मैं भी सच बोल रहा हूँ, और ये हम दोनों का सच मिलके ये एग्जिस्ट कर रहा है. तो आपका एक फिजिकल डेफिनेशन हो सकता है फिजिक्स का डेफिनेशन, मेरा केमिकल डेफिनेशन है केमिस्ट्री का डेफिनेशन. क्योंकि इफ आई कॉल ए केमिस्ट्री, वो तो बोलेगा एंटायर यूनिवर्स इज केमिस्ट्री, अब बोल रहे हैं एंटायर यूनिवर्स इज फिजिक्स. साथ दोनों सही बोल रहे हैं.
हाँ, ऑफ कोर्स.
ओह यस, आई एम गेटिंग इट रॉन्ग. ओह माय गॉड, जी.
So, Dr. Kunal Borah, Associate Professor at NERIST in the Department of Physics. How are you, sir?
Very fine, thank you. How are you?
I'm good, sir. So, sir, you are here because I wanted a conversation strictly in the universe of physics. You are the man, so you are here. So, if you had to explain physics to a teenager, or let's say even somebody lesser of an IQ than a teenager, let's say 10-year-old, how would you explain it?
First of all, thank you to you.
Later.
So, thank you for inviting me over here.
Yes.
It's a very good work that you are doing.
This all.
Yeah, this work, and of course, your academics also are doing good. Yes, you have asked or you have introduced me with a humble introduction you have given. But like, first thing that I would like to say that I am not a professor of physics.
What are you then?
I am a student of physics.
Oh wow. Then tell me what have you done this scholar?
And you cannot finish learning physics in your lifetime. That is the first thing you should. Everyone should know.
Okay.
I think it is applicable to all the subjects.
All right. Well,
And if I come to your question, what would I tell a 10-year-old guy
or a girl.
or a girl? What is physics? So in that context, I would like just like suppose a boy is playing his football. Or a girl is playing his football or playing football. He or she kicks the ball, goes into the air,
Yeah.
falls down.
Yeah.
That is physics.
Yeah, natural phenomenon.
That is physics.
So are you saying that physics just with natural phenomenon?
Yes. Nature, if you want to learn nature, if you want to know how things are occurring around you, how why the leaves of the tree falls downwards, why you keep the ball upward and again it goes upward and falls down, why it was standing. So everything, why you see sunrise, why you see sunset, everything. Even a 10-year-old guy can ask this question and get create this inquisitiveness inside in him or her to study physics. I would just like to ask one the guy a small question. So, you know why sunrise is occurring? Why is rising? Simple questions. So once you start asking how and why these two questions, you start learning physics.
Okay, let me tell the audience, when you mention nature, you actually mean the phenomenon of the universe, right?
Yes, of
You don't mean the literal term that people say that I love nature, मतलब उसको हवा, पानी, पहाड़, पेड़, पौधा पसंद है. You're not talking about that, right?
Of course, since we are talking about physics,
Hmm.
I am bounded to the
That-
boundary that area.
Okay. क्योंकि बहुत लोग नेचर का मतलब ही वो पकड़ लेता है.
हाँ, someone may think like that, but of course.
तो इसलिए मैं clarification दे रहा हूँ. So you said why and how. Why and how could be human as well, but वो जैसा बोला वो matter से related होना. Okay. तो ये तो हुआ एक definition to a 10-year-old. BSc students?
BSc students. See, when we talk about, I mean, when we go to students का क्या है कि suppose BSc student has come up to for his first year classes, and I have to teach. Suppose I have to teach electricity, magnetism, or mechanics, whatever. So I assume, as a teacher in the classroom, I assume that the student has learned a bit of physics earlier in his 10 and plus 2 level. He or she has learned something in physics. So in that perspective, he or she would have loved physics in the earlier stages of his academics, like plus 2. That's why he has come to study BSc in physics, or he is interested in science. So my definition will be, or I will not define physics for them.
Okay.
Rather, I would like to introduce physics in a newer way to them.
बताइए वही.
Newer way in the sense कि what I do usually.
और सर आपने जब साइंस बोला अभी फिजिक्स और साइंस, फिर साइंस का डेफिनेशन भी तो वाई एंड हाउ है ना.
Exactly.
तो फिर साइंस और फिजिक्स में अलग क्या हुआ? अलग तो है लेकिन ना.
Science and physics में अलग
साइंस इज ओवरऑल.
suppose literally if I talk about science, what क्या आता है ना हम लोग के माइंड में कि साइंस होगा तो it will be mathematics, it will be chemistry, it will be physics, it will be engineering, there will be biology.
Biology.
So everything is there. But see, this concept is very old now.
Well, really?
This concept is very old. It is like everything is, you can say, amalgamated as of now.
Okay.
Earlier it was discrete.
Discrete.
Physics, chemistry, mathematics. Now no, you cannot say, you can separate them.
अब फैमिली है साथ में रहते.
So whenever I talk about physics, if I go into, suppose I want to make you understand structure of a matter, then I have to go to atomic level.
You have to, yeah.
Then chemistry comes into play.
Yeah, when you, yeah.
Electronic configurations come into play. Pauli exclusion principle come into play. So all those type of, so you cannot run away from chemistry if you study only physics. You cannot run away from mathematics if you study only physics. It's not like that. So हाँ आप जैसे बोला है कि साइंस ही तो है, हाँ साइंस ही है. सिर्फ फिजिक्स से साइंस नहीं चलता है. लेकिन ऑफ कोर्स पहले भी मैं बोला हूँ बिकॉज आई एम ए लवर ऑफ फिजिक्स. सो मुझे अच्छा लगता है कोई भी साइंटिफिक फेनोमेना को इन टर्म्स ऑफ फिजिक्स एक्सप्लेन करने के लिए.
इन टर्म्स ऑफ फिजिक्स
एक्सप्लेन करने के लिए मुझे अच्छा लगता है कि उसमें मैं फिजिक्स ढूंढने की कोशिश करता हूँ. व्हाट इज द फिजिक्स बिहाइंड इट. देयर विल बी केमिस्ट्री, देयर विल बी बायोलॉजी, बट आई एम मोर इंटरेस्टेड इन द फिजिक्स पार्ट. जैसे आप बोल रहे थे ये बीएससी. So when we BSc के students को they come, so either they have learned physics in the earlier classes, that's why they have come, they love physics, maybe or due to compulsion कभी-कभी हो जाता है घर के प्रेशर में.
घर के प्रेशर में बीएससी फिजिक्स हो जाएगा, वो कुछ भी ले सकता है.
नहीं हो सकता है,
हो सकता है, of course है.
क्या पता इंजीनियरिंग मिला नहीं
हाँ.
तो बीएससी फिजिक्स में आ गया, बिकॉज इंजीनियरिंग इज क्लोजली रिलेटेड टू फिजिक्स, तो क्या पता वो फिजिक्स में आ गया होगा एज ए ऑप्शन बी. तो my prime motive is to motivate that student and keep him studying physics. And for that, जो मैं करता हूँ, मैं जैसा सोचता हूँ, what I think is that physics sometimes किसी को ऐसा लगता है कि they think that it's a very tough subject.
Yeah, of course. Physics is supposedly called a tough subject.
It's a tough subject, and in our days, if somebody take in BSc, the combination is physics, chemistry, mathematics, they call it as what? It's the royal combination.
Royal combination.
They call it royal combination. I don't know. Today also they call it also. Not I don't know about that. But in our days, in 2000s. So they call it as a royal combination. And if you take physics major in BSc, it's a people think that
Royal का महाराजा.
हाँ ये तो बहुत जानता है. It's not like that actually. Physics tough बोला जाता है, but जो मुझे लगता है, if you love to study stories, story books.
Interesting. कहाँ जा रहे हो? I'm interested.
Yeah. I'm drawing the philosophy. If you love to study storybook, or if you love to see a very good film, you will be a good physicist if you insist on that.
It is not convincing me.
Yeah, I will go.
क्योंकि story हो, movies हो, they need not have logic.
Yeah, मैं आपको philosophy इसीलिए मैं बोला, you need to learn the philosophy.
Okay.
So what happens in a good film? What happens in a good story? There is a flow.
There is a flow. That's correct.
So there is a story behind it. You, in a good film, in a very good novel, the characters will be introduced to you first.
Yes.
The plot will gradually develop, and there will be a climax, and you'll get a result out of that. A good story. Sometimes you may not get a good result, but usually there will be a happy ending.
Nonetheless, there will be a result. Good, better, ugly, result तो आएगा.
हाँ, result तो आएगा, कुछ भी है. तो physics को हमको tough क्यों लगता है? Because too much of mathematics, बड़ा hard concept. You give someone to derive a equation from electricity magnetism, they will feel अरे कहाँ से ये आ गया, कहाँ से वो आ गया, यहाँ पे charge density कहाँ से आ गया. They feel like that. So if you are a very good a movie watcher or a very good person, if you love to study a story, or if you love to hear a story, you can see the flow of a mathematical derivation in physics. It is like a story. You define the terms.
Yeah.
What is a plot? What is a diagram in a whenever we do a derivation in physics, we first draw a diagram. In some topics in physics, we first draw the diagram, right? What is a diagram?
Diagram is like, let's say, a gist or a trailer. I don't know.
It's a screenplay.
Screenplay, okay. All right.
So you're drawing the diagram. You are setting the whole thing. This will be this thing. This will be my plot. I will be playing around this plot.
Correct. There's a core.
Then what you do?
Then we write that we know that this is.
Or you define the terms that you have written in the diagram. A, B, C, D. Let A be this. Let B be this.
Yeah.
Let us consider that the hero is from a lower background. In movies, in stories also we do that.
I'm somewhat getting what I'm trying to say.
So you define the characters. Now there's a villain in the movie. He has done something wrong to your family.
Yeah.
Right?
Yeah.
And you want to establish that is wrong.
Yes.
That's what he was doing.
Yeah.
So for that you have to set something which is correct. and you have to do it in a very systematic manner.
It has to be systematic.
So that is what a derivation is in physics.
Yeah, derivation.
You want to derive a formula for force at the end. So very crudely, if I speak, force is something. If you go to Newton's law, it's mass into acceleration. So you should know what is. You should know an expression for mass. You should know for an expression for acceleration. Then only you can derive a formula for force for that. So मास और एक्सीलरेशन को निकालने के लिए हमको जो फ्लो से आना है, that is a story. You should feel it.
Okay.
Until and unless you feel the derivation as a story, you will never love physics.
You will never enjoy physics.
You will never enjoy physics. You will never love physics. You should understand that इसको देख के आपको मुस्कुराना है. आपको जैसे पढ़ के आ रहे हैं ना, तो you just feel you should love. धीरे धीरे मुस्कुराना है. अच्छा ये यहाँ से आ गया. अरे सर बोला था, हाँ ये m कहाँ से आ गया? ओके यहाँ से आया है. वो जो एक्साइटमेंट है ना, ये आपको आना होगा. And that is same as we read a story, very interesting story.
I got the point.
I think am I clear?
All right. Let me review what you have just said. My first question was, I asked you to define physics to a 10-year-old. You said whatever happens and whatever you see, whatever phenomenon you are witnessing, if you question it, the answer is physics for a 10-year-old. Then I asked you what should be the definition of physics for, let's say, undergraduate students. And you say that the undergraduate students now go to a higher level of understanding physics where necessarily he has to derive something. So the derivation has to be taken in a way that a story is running. And when you say story is running, first of all, there's a plot of the story, the major plot, because everything runs in and around that plot. That is the diagram of the physics. And then when you try to define the plot, you have to give some character, some name, and then those names will play their own roles, and suddenly you have some climax. And that's how derivation happens. And actually, if you look things this way, I think physics will be quite interesting. Correct.
I hope so.
Okay. What's the theoretical definition? एकदम bookish definition बताओ. ये तो हो गया आपका definition.
Law of nature.
Law of nature is
Physics
science.
is the law of nature.
Law of nature is science. If I have to put it.
Yeah.
So, but science is not,
You may put it like that.
science is not physics. Biology is not physics.
No.
Chemistry
why?
is not physics. Chemistry is not physics.
No, chemistry is not physics. Okay. Science. I mean, chemistry is not physics. Biology is not physics. That is what you're saying.
Yeah, but they are science. These are science.
Actually, when we say nature or law of nature, we actually go to our existence.
So let us not go there now. Really,
Oh.
we are jumping there right out.
No. Existence in the sense ki how universe is working.
Okay, so even before we go there, I'll just interrupt you here. Okay, let us try to connect chemistry with physics. मेरे को जितना समझ है, chemistry simply means there is an energy interaction between two matter, two atoms, two quark particles, two protons, two electrons, whatever you call it. There's an energy interaction, and I mean, because of the play of energy, one might engulf it up another, and they form compounds, they form alloys, whatever, composites, whatever. All right. Now, when I say that, it's a play of energy, and one particular matter is getting attracted to another particular matter. The force of attraction again comes out of physics, and because of the force of attraction, only chemistry happens. So without physics, chemistry cannot happen.
Yeah.
So that way,
I already told you.
that way they are connected.
Nothing can exist in a solitary manner.
That way they are connected. But you are giving an umbrella term that physics is law of nature, and I have.
So you asked me the theoretical definition.
So there should be a more specific theoretical definition, no? Let's say law of nature that involves physical matter. I don't know what how to put it. Or we can create a definition right away. But law of nature is no. I mean we are nobody claiming that we'll write a book on it. But law of nature is science. It's better. It's to be called as science than physics. ये मेरा आपसे हल्का सा ग्रुप डिस्कशन बोलते हैं ना, डिसएग्रीमेंट है.
हाँ, डिसएग्रीमेंट हो सकता है. I completely understand what you're saying, but the thing is that if you ask me exactly the theoretical definition of physics, the bookish definition of physics, this is the bookish definition of
ऐसा ही है.
ऐसा ही है. लेकिन वही है, मैं इसको पहले भी I told you कि you cannot separate chemistry from physics or physics from chemistry. There will be these things. I mean, collaborative works.
Now chemistry is dependent on physics.
Physics is dependent on chemistry.
Likewise. Oh yeah.
Vice versa is
Everything is chemical reaction.
exactly.
Everything is chemical reaction and everything is physical phenomenon. Physical phenomenon in physics, chemical reactions chemistry. तो वही है ना.
You cannot define solely formation of a material from out of your chemistry lab. You cannot define the formation of material out of a chemistry lab with only chemistry.
हाँ.
There has to be some physics behind it.
तो इसको हम ऐसा बोल सकते हैं क्या कि ऐसा बोल सकते हैं क्या, जैसा कोई ये कप है, कप है ट्रुथ, सच्चाई. ठीक है, कैमरा में कप आ रहा है तो दिस इज द ट्रुथ, दिस इज सच्चाई. आप उस लेंस से देख रहे हो, आप भी सच बोल रहे हो, मैं इस लेंस से देख रहा हूँ, मैं भी सच बोल रहा हूँ, और ये हम दोनों का सच मिलके ये
एग्जिस्ट कर रहा है.
तो आपका एक फिजिकल डेफिनेशन हो सकता है फिजिक्स का डेफिनेशन, मेरा केमिकल डेफिनेशन है केमिस्ट्री का डेफिनेशन. क्योंकि इफ आई कॉल ए केमिस्ट है, वो तो बोलेगा एंटायर यूनिवर्स इज केमिस्ट्री, अब बोल रहे हैं एंटायर यूनिवर्स इज फिजिक्स. साथ दोनों सही बोल रहे हैं.
हाँ, ऑफ कोर्स. मैं इसीलिए आपको पहले ही बोला कि एज ए स्टूडेंट ऑफ फिजिक्स एंड लवर ऑफ फिजिक्स, आई वुड लाइक टू डिफाइन ए फेनोमेना इन टर्म्स ऑफ फिजिक्स. The same phenomena can be defined in terms of chemistry also.
Yes. आप पहले डिस्क्लेमर दे.
ये बोल दिया
मेरा लेंस तो वही है, मेरा चश्मा तो वही है.
वही. इसीलिए मतलब इट्स वेरी डिफिकल्ट टू डिफरेंशिएट एक्चुअली.
हाँ.
और जैसे आप अभी बोल रहे हैं, जैसे इफ सपोज आज के दिन में व्हाट इज हैपनिंग इज लाइक फिजिक्स को आप इफ सोशल मीडिया पे भी चले जाएं या फिर इन कॉमन youth platforms, maybe it's a social media or some other platforms, clubs and all, physics को एकदम बाउंड कर दिया है something related to astrophysics or how universe works, black hole, wormholes. हुआ है. I'm telling,
हम भी इस तरीके से सोचते हैं.
Exactly. But the thing is that if you see the pool of physicists who are working or doing research in physics in India, abroad as well, we'll see very less amount of people are working in this area. The major chunk of physicists who is working doing research in physics are doing research in material science, and which is a mixture of chemistry and physics.
And in the broader term, it's a mechanical engineering domain.
हाँ, of course.
हम लोग मेटेरियल साइंस से पढ़ते हैं.
See, now
मैं अलग चश्मा लेके यार, let us not go there.
नहीं वो तो है ही. See, अभी मैं बोलूँगा कि या अभी ऐसे बोलने से आपको
खराब तो नहीं लगेगा सर, प्लीज गो.
जैसे हो गया कि फिजिक्स gives you the, I mean, engineering is the application of physics basically.
वो एग्रीड है.
वो तो है. तो जितने भी whatever branches that has come up like mechanical हो या electrical,
वो भी है.
The basics is always physics.
Correct.
So you cannot separate yourself from physics. Physics रहेगा. I am a what to say, a teacher of physics in a engineering university. So it will be there. You cannot deny that. तो वो है. तो यही मैं बोल रहा था. जैसे अभी लगता है कि फिजिक्स सिर्फ वही है क्या? If someone is giving a classic definition of wormhole with a very good background music.
आ रहा है आजकल रील्स चलता है.
हाँ, रील्स चलता है. So you will become like, oh, is it so? If universe bends like this or this that, how time space time anomaly create हो गया, ये हो गया, वो हो गया.
इतना theories है lately.
That is theory, but I'm not denying कि that is not that is wrong or something. That is very interesting. I am also very much interested in studying on those things. Actually मैं कभी ये नील देग्रास का वो पॉडकास्ट सुनते सो जाता हूँ. आई लव हियरिंग. लेकिन माई फील्ड ऑफ रिसर्च इफ आई से is electronics basically. What is the application of physics?
Really? Okay.
So I deal with materials also. I worked on developing new materials for electronics devices. So physics वो भी है. जैसे you were stressing on the chemistry physics को combine करने का बारे में आप जैसे बोल रहे हैं कि there is a amalgamation of two atoms in a matter as form. So that is what I also do in my research. See, without nanoscience and nanotechnology, your phone could not have been so thinner.
Yeah.
Isn't it?
Absolutely.
So, for this advancement of technology, this whatever gadgets that we're using, every day new things are coming up, new technologies are coming up, not only due to only physics. It is due to chemistry, due to physics. Everything is involved there. Material science. Your battery has become thinner because the electrodes now we use is a very thin films. Right? So, when we talk about thin films, we have to talk about chemistry of thin films.
Yes.
And when we talk about use of that thin films in battery and make it applicable to a device, we talk about physics. So when we characterize that thin film to study whether it is eligible to be used in a technology, we do physics. So it's a very खिचड़ी
नहीं बोलेंगे.
खिचड़ी तो नहीं बोलेंगे.
It is like physics is indispensable for any kind of engineering application or scientific exploration or investigation. Physics is मतलब वही background है. मेरे को जो समझ में आ रहा है ना वही background. Okay. तो सर अल्बर्ट आइंस्टाइन को आप साइंटिस्ट मानोगे कि फिजिसिस्ट मानोगे?
अल्बर्ट आइंस्टाइन एक ऐसा पर्सनालिटी है इन द फील्ड ऑफ साइंस जो यू कैनॉट बाउंड हिम टू एनी सब्जेक्ट एग्जैक्टली. मैं ये बोल सकता हूँ.
तो मतलब आप
वो हम उनको फिजिसिस्ट भी मान सकते हैं. यू कैन कॉल हिम ए गुड साइंटिस्ट.
Can you call him a philosopher? No?
Yeah, he's a philosopher too.
वो भी बोल सकते हैं.
See, philosopher बोलने से see the whole theory of relativity, either it is a special theory of relativity or then GTR or STR that we call.
क्या है GTR STR?
Special theory of relativity.
Special theory of
and general theory of relativity.
Okay.
And ये सब चीज़ें philosophical है. It was first philosophical and he turned the philosophy into mathematics, which is now physics.
Okay. All right. Now you gave an interesting definition of physics again. Philosophy, if converted into mathematics, and when you have mathematics, you can denote some
Interpret the equation
in the physics term as well.
Yes, of it. Physics speaks in the language of mathematics basically.
तो सर ये एल्बर्ट आइंस्टाइन का जो सो कॉल्ड इक्वेशन है E = mc स्क्वायर, मैं बहुत मैं ऑल द इक्वेशन कॉन्टेक्स्ट में मुझे को मालूम है कि व्हाट डज इट एक्चुअली मीन. मास है, स्पीड ऑफ लाइट है, उसका स्क्वायर है, विद दिस एनर्जी हियर है. लेकिन व्हाट एक्चुअली वेंट इन आइंस्टाइन्स माइंड जब वो उसको डिराइव किया था या उसको इंट्रोड्यूस किया था, मैं कभी शायद कॉम्प्रिहेंड भी नहीं कर पाऊँगा. व्हाट डिड ही एक्चुअली मीन? तो you are a physicist, you are closer to him than me. तो आपको अगर एक्सप्लेन करना होगा मुझे या किसी को भी this theory of relativity.
No, it's not theory of relativity as such, but
what is theory of relativity?
that is another this thing. That is E = mc square is something it's called like mass energy equivalence.
Oh yes, I'm getting it wrong. Oh my god, gee. हाँ तो
No, you're not getting it wrong exactly, but it's not like that.
No, confuse हो गया. Confuse नहीं मतलब ठीक.
हाँ, इस मास आप बोल सकते जो भी है. You can use that in relativity as well, but it is a mass energy equivalence, whatever, like it's a relation between mass and energy basically. If you see the equation itself, E = mc square. So c is the speed of light, m is mass, and energy is yours. So if you want to understand E = mc square completely, you have to understand the philosophy behind how he has derived this equation.
That's what I want to understand.
But the thing is like, if I go into those it will be a bit very long process and very deep dive into the whole thing. And just
Will it take time?
Yeah, it will take some time. But I can give you a very
I actually want to.
as what you just said. You just make me understand what is E is equal to
Okay, yeah.
I can make you understand what is E is equal to mc square. It's called mass energy equivalence. How mass is related to energy. How you can convert mass into energy.
Okay.
How you can convert mass into energy. What amount of mass will represent what amount of energy.
Potential of the energy that a mass can have.
That is what we can say nuclear fusion.
Mm-hmm.
The energy produced in fusion.
The sun.
How sun works.
How sun operates.
It goes to atom bombs.
Huh.
So you can have a idea now.
Roughly idea.
Yeah, as a layman, if you don't know what is E is equal, but you see everywhere. Whenever you see a physics slide, you see E is equal to mc square. Now at least you can say, okay, E is equal to mc square is like the conversion of mass into energy. How a tiny bit of energy, like a small bit of energy, multiplied by the square of speed of light will give you so much amount of energy.
Tiny bit of mass can actually give
This much amount of energy.
जो
Multiplied by
c square.
c square.
जो एटम बम
That is the simplest way I can make someone understand.
इतना छोटा सा एटम बम भी
उतना छोटा सा यूरेनियम
हाँ
आपको
पूरा दुनिया डिस्ट्रॉय कर सकता है. हाँ. Okay.
I mean
I understood. That's what I said. I mean that's why I tried to take it from you that the potential of a mass तो उसमें कितना एनर्जी हो सकता है. Possibility.
हाँ वो you can.
Possibility. Provided it वही उसका स्पीड पे डिपेंड करता है of course.
हाँ वो c square तो फैक्टर इज
फैक्टर तो है ना तो उस पर डिपेंड करता है. तो अगर मैं एक तो मास हूँ जो हूँ अभी लेट्स से आई एम
of course
रफली 60 किलो का मास हूँ तो मैं स्पीड ऑफ लाइट का तरफ से हो सकता हूँ तो मेरा एनर्जी कैन डिस्ट्रॉय द यूनिवर्स.
yeah ample amount of charge can go. So don't be so destructive.
So there's something called Newtonian physics, also called as classical physics, and quantum physics. उसके बारे में थोड़ा बताइए तो.
Quantum
The purpose of our conversation is to educate myself and to my viewers.
हाँ जो quantum physics and classical physics the different differentiation, isn't it? I mean how they are different. Right? So एकदम if I want to make your you are not you are very educated and you know physics. I think you know physics more than me. I think.
Okay.
No, I mean you're a good student of physics, and without that you cannot be a mechanical engineer.
All right. So
if I want to make someone understand quantum, because this word again I'm telling you, this word is like a viral word in everywhere. Quantum. Anyone related to science and technology has heard this term quantum. As lately, it is quantum computing that is coming up.
Yeah.
Or government of India has also launched quantum mission.
Quantum what?
Mission. As it has launched nano mission in 2000.
Okay.
Now it is launching quantum mission.
Okay.
The difference between classical and quantum or mechanics is very simple. Very simple. When bulky matter, we are explaining the kinematics or dynamics, or you can say mechanics basically, of a bulk matter, of a very big football, let us say.
A proper mass. Bulky mass.
A bulky mass. Then it is classical mechanics.
Then Newtonian mechanics.
Nature.
Force equal to mass into acceleration. So mass is taken as mass only.
Mass only. When you go into the matter, when you dive deep into the matter, you go into the atomic level.
In a subatomic
level. If you go there, if you want to study the mechanics of those particles, it is quantum mechanics.
So, sir, if you actually go as deep as possible, you won't find any matter actually. It will end up being empty space, is it not? Is it not?
Yeah, as we say, it is like that only. It's
Right. It's these are all waves only, vibrating at different frequencies, and if the frequency is, I mean, in the order of billion, then it might take the shape of a solid. Less than that, it takes the form of a fluid, or likewise, whatever. I don't know if I'm making any sense. Because I can only think about it. I haven't seen things that way. There are atoms, and let's say I'm talking about two atoms. All right. Every matter attracts every other matter is what we understood as one of the laws of nature. Like right now I'm here, and some matter is in Jupiter. I'm still a possibility that I might get attracted to that, but it's not absolutely, chances is not zero.
the distance also matters.
That's exactly, it's never zero. It's nearest to zero is but not zero. So as we come closer, and as we come closer, just to conserve energy, attraction is more now. Like if I come closer to you, I'll get more attracted to you in the physics terms. All right. So
Mass to mass.
mass to mass. So when it supposedly means that one mass should meet the other mass because of whatever I've just said. But when they actually come closer, there's a force of repulsion as well. Exactly when they come very close, because of a mass always has a certain energy band with it. So when they come closer, there's some force of repulsion, and so it might go away. But then if it goes away, then again the energy, that attractive force, is also bring it together. So at a certain distance, neither the force of attraction nor the force of repulsion, they cancel off each other basically, and you have a bone length where they are happily coexisting each other. So the two atoms are separated. They're not exactly in contact, and they are perfectly fine in equilibrium. Right, sir? 1 second. So, but that actually means they are not in contact. They have a line which is not a physical line, about which they will get attracted.
There's a void.
There's a void. Now this is in the atomic level. Now again, if I go subatomic level, the same principle will apply there. There will always be a gap. They will not be like this. Two matters won't be in contact with it. There will be a gap. So if there's always a gap, then this entire universe is a void. There's only gap. इसको क्या करेंगे सर? इसका क्या करना है? इसका क्या तोड़ है?
If let me give one simple example to understand this. Like suppose this wall is also made up of particles, basically atoms and all. So void spaces are there. As you have said, my body is made up of
matter, atoms.
So I have also void spaces in me. Right?
Right.
So if it is like that, I can move, I mean, from this side to that side of the wall from the void spaces.
No, because...
Or if I stand like this, why don't I fall down?
No. So that's because you have void spaces, but still we are structured in a certain way that the so-called void spaces, जिसको हम उसको थोड़ा सा बड़ा में एटॉमिक एटॉम भी बोल देगा, तो एटॉम का तो एक certain arrangement अपना होता है, which cannot be compromised with. तो नहीं तो आपका structure ही कुछ मतलब हुआ नहीं बा. So that way, I don't know if that's what I'm saying.
Actually,
ये चीज थोड़ा सा
void spaces
समझना मुश्किल है.
समझना मुश्किल नहीं है.
आप बताइए तो समझा.
You have given the answer yourself.
क्या बोला मैंने?
कि दो मैटर है, दो पास में आ रहा है, but there can be repulsion between them.
There will be actually.
There will be, and so if there is a repulsion between them, they are coexisting in such a manner that there will be a space between them, and they are coexisting in that.
Stable हो गया.
तो whole thing lies over there only. आपने stable बना दिया ना उसको.
बना दिया तो मैंने.
तो हो गया, एग्जिस्ट कर रहा है वो.
तो वही फिलोसॉफी को अगर मैं लेके गया, तो एटम का अंदर में भी जो सब एटॉमिक पार्टिकल है, वो भी इसमें भी गैप है, फिर भी गैप है,
वॉइड स्पेसेस है.
तो मतलब एक मैं इन्फिनिट सिमल्स अगर मैं अंदर जाऊंगा तो वॉइड स्पेसेस रहेगा और मैटर भी रहना पड़ेगा ना. अगर मैटर ही नहीं तो किसका बीच में स्पेस है?
नहीं होगा. वॉइड स्पेसेस तो मैटर.
एग्जैक्टली. नाउ मेरा थोड़ा बत्ती खिल गया है. अगर मैटर नहीं रहेगा तो स्पेस किसका बीच में है? स्पेस को एग्जिस्ट करने के लिए टू से दैट देयर इज अ गैप बिटवीन अस, आई एंड यू हैव टू एग्जिस्ट.
यस.
हम दोनों ही एग्जिस्ट नहीं करेगा तो कुछ गैप ही नहीं हम दोनों का बीच में. और मैं सिर्फ गैप पे ध्यान दे रहा था कि हर जगह गैप ही है तो एवरीथिंग इज वॉइड.
हाँ वही.
हाँ,
ऐसा नहीं है. वो आप जो अभी बोल रहे हैं वो यू आर करेक्टिंग योरसेल्फ बेसिकली.
आई सेल्फ करेक्ट है. क्योंकि सी एज मैकेनिकल इंजीनियर्स हम लोग यहाँ तक नहीं पहुँचते हैं.
जी जी.
हम मोस्टली हमारे न्यूटन फिजिक्स होता है, क्लासिकल फिजिक्स. मास को मास बोलते हैं, आगे बोलते हैं. वी बिलीव इन द, वी एज्यूम द कंटिन्यूम कॉन्सेप्ट कि इट्स ए कंटिन्यूअस मास, बट इट इज नॉट.
यस.
वही वॉइड रहता है, बट सिर्फ वॉइड रहने के लिए मैटर को होना जरूरी है, तो मैटर भी रहता है.
हाँ, तभी तो एग्जिस्टेंस होगा.
नहीं तो फिर सबको नल एंड वॉइड हो जाएगा, सबको जीरो में आ जाएगा. हाँ, इंटरेस्टिंग ना. तो डीप चला गया था. दैट्स व्हाट आई वांट एक्चुअली.
नहीं होता है. और फिजिक्स व्हेन वी टॉक लाइक दिस, नो, सम पॉइंट विल कम
हाँ,
वेयर यू एंड मी विल बी जस्ट नम. आपको ऐसा लगे मैं क्या बोल दिया? इज इट मेकिंग सेंस? if we talk very in a very candid manner, तो ये होता है.
तो अभी थोड़ा देर पहले हुआ.
हाँ, स्क्रिप्टेड होने से नहीं होगा.
अभी मैं खुद ही बोल बोल के फिर सोचा
तो you will make you
ये क्या हुआ.
you will correct yourself. You'll think that यही तो है physics basically.
And this is the first time I'm talking with somebody who studied physics. मुझे कभी मौका नहीं मिला. That's why मेरा कन्वर्सेशन यहाँ तक पहुँचा. नहीं तो मैं किसी को बोलूँगा मुझे भगा देगा, क्या बात कर रहा है, भाग साले वो.
यही तो ब्यूटी है ना फिलोसफी का. This is the philosophy of physics basically.
Have you watched are you a Marvel fan? Marvel movie, Marvel universe fan?
मैं सुपर हीरोज का मूवी इतना देखता है.
But आपको आइडिया है ये एंटमैन का बारे में?
एंटमैन सुना, वो जो छोटा हो जाता है.
छोटा हो जाता. इसमें मेरा एक फ्लो मैंने पकड़ा है, आप उस पर थोड़ा कमेंट कीजिए. एंटमैन वो सब एटॉमिक लेवल पे वो छोटू हो जाता है. व्हेन आई से सब एटॉमिक मतलब एटम से भी छोटा है, एटम्स का अंदर घुस के. सब का मतलब वही हुआ ना.
हाँ, छोटा हो जाए. आई डोंट नो एग्जैक्टली. हाँ बोलिए आप.
ओके. लेकिन वो अंदर भी सांस लेता है. सेंटिएंट बीइंग को, ह्यूमन बीइंग जो सेंटिएंट है उनको तो ऑक्सीजन चाहिए ना जिंदा रहने के लिए. लेकिन ऑक्सीजन का साइज तो सब एटॉमिक नहीं होता, एटॉमिक है. अगर वो O2 है तो दैट इज नॉट सब एटॉमिक. ओ एलिमेंट अपना एक साइज लेके आया है ना.
एंटमैन इतना छोटा हो जाता है.
यस, वो कहाँ घस जाता. मूवीज में तो ऐसा ही दिखाता है. तो सांस वो मतलब वो ऑक्सीजन एटम से भी छोटा हो गया एक्चुअली. लेकिन उसको
तो छोटा नहीं दिखाता होगा.
दिखाता है, मतलब आई मीन उसका
इनविजिबल हो जाता है.
इनविजिबल नहीं हो, एज स्मॉल एज वी कैन. आई डोंट नो इफ आई एम मेकिंग करेक्ट स्टेटमेंट, बट मुझे तो वही देख के लगता था.
सो इनविजिबल हो जाता है. कभी कभी ट्रेलर्स देखा हूँ.
अच्छा, सब एटॉमिक छोटा हो ही नहीं सकता ना. नहीं तो
उतना तो नहीं होगा.
तो जिंदा नहीं रहेगा, क्योंकि
जिंदा ही नहीं रहेगा शायद. इवन अगेन सी मार्वल एंड ऑल दोस थिंग्स आर वेरी.
लॉजिकली जैसा मैंने बोला, ऑक्सीजन एटम से तो बड़ा होना ही पड़ेगा, तभी तो वो सांस ले पाएगा.
हाँ, अगर उसको जिंदा रहना होगा
सांस तो लेना पड़ेगा ना. जो भी जिंदा है, एवरीथिंग दैट इज सेंटिएंट.
अगर एक ऑक्सीजन का वो भी आपका उससे भी छोटा हो गया तो आप उसमें घुसेगा कैसे? हो सकता है. इन ए वे आई अप्रिशिएट योर इमेजिनेशन एंड ऑब्जर्वेशन. लेकिन आई डोंट थिंक कि एंटमैन को इतना छोटा दिखाया गया है.
आई डोंट नो, मुझे तो आई हैव टू रिविजिट दोस मूवीज. मैं
क्योंकि ट्रेलर्स में देखा हूँ तो जॉन अराउंड छोटा हो जाता है. मैं आई हैव दैट आइडिया. इतना भी नहीं हो कि मैं नहीं देखता.
नो, वो एक्चुअली क्वांटम लेवल तक छोटा होता है कुछ होता. एनीवेज, लेट्स नॉट डिस्कस देयर. मतलब मेरा ये कमेंट था जो आपसे शेयर किया फ्रॉम द फिजिक्स पॉइंट ऑफ व्यू. अगेन फिजिक्स मीन्स जैसे मैटर, यू स्टडी मैटर. वो फिजिक्स मटेरियल्स हैं, वो मैटर मटेरियल द सेम थिंग. लेट्स पुट इट दैट वे. तो आई डोंट नो इफ इट्स अ राइट क्वेश्चन टू आस्क यू. मे बी कंक्लूडिंग क्वेश्चन ही पूछूं क्या? फिजिक्स और गॉड का कुछ कनेक्शन है? ना, वी शुड नॉट गो देयर.
फिजिक्स और गॉड का क्वेश्चन, मैं हमेशा ये एक बात मतलब सी आई बिलीव इन गॉड बेसिकली. सो गॉड कभी कभी ऐसा लगता है इलेक्ट्रॉन भगवान है.
वही, नाउ यू आर कमिंग टू द पॉइंट. हाँ, बताइए आपका क्या दिमाग में चलता है कि इलेक्ट्रॉन भगवान लगता है?
तो कैसा लगता है? तो व्हाट आर द कैरेक्टरिस्टिक्स ऑफ गॉड? आई एम टॉकिंग अबाउट इन टर्म्स ऑफ माय रिलीजन. ओके, दैट इज गॉड बोलने से यू हैव टू बी स्पेसिफिक. व्हाट इज आई हैव बीन टॉट अबाउट गॉड.
ओके,
so I belong to basically. तो हमारा उसमें what I believe is that God is omnipresent. It is present everywhere.
Everywhere.
I think in every religion it is this, and it has no shape.
Nirakar.
Nirakar. And without God, there will be no existence of anything.
Correct. Correct.
Right? So these are the 3 points basically that define what. I'm not going to define God. I don't know. It is.
I just wanted you to connect if you are comfortable.
No.
Physics with God.
Yeah.
Only if you are comfortable.
But I don't think it should not become controversial in that way.
That's why it's only if you are comfortable.
Yeah. But see,
Not picking up any religion. I'm just saying.
I'm not picking up any religion. I'm just saying that God is omnipresent. God has no shape.
Nirakar.
God is everywhere, and God gives you energy to exist. Or without God, no one can exist in this world.
God is also called as Nirguna. It has no qualities, no characteristic, no attributes.
But
You cannot define attributes. No, these are attributes. That's
yeah.
Okay.
Just main points, the main characteristics that I'm picking up. So it is like electron. It has no shape. Electron has no shape. Do you know that? How we draw an electron in a
circle,
in a black hole? Circle. Do you know? Is it correct?
I've never inquired.
Nobody has defined the shape of electron exactly till date. There are models.
There
are models.
Yeah.
Say that electron has this shape. Electron has vortex shape or something like that.
Okay. Yeah.
But exactly why we draw it as a circle? Because it is the most stable shape in this universe. We draw it like that. Without electron, anything can exist?
No. All the chemistry is by the play of electrons.
Without electron, we will not exist.
And I think the universe is a play of chemistry only, as I've said. And there are chemical reactions.
Electrons are present everywhere.
Yeah, they are everywhere.
It is around us.
Yeah, every entity is made of electrons.
Yes. So sometimes I feel like that. Can you relate now?
Yeah. That's what I wanted to know. How do you think as a physicist?
Yeah. And there is a power, if I say. There has to be something.
Yeah, of course. There has
in Principia, Principia Mathematica, the book of Sir Isaac Newton, where he has written the laws of physics, laws of motion, everything he has derived and given the expressions. This is his book. So in Principia Mathematica, Newton itself has agreed upon that this is the point I have come, and after this point, my laws cannot define anything. And to define this beyond this point, there has to be something that I think that is God. Even Newton has said.
No, that makes sense to me. I mean, he could go as far as his mind could go. He could go as far as his equations could go. He could go as far as theory can go, and he stopped somewhere. And now, if there has to be anything beyond this, it has to be God.
It has to be God. It has to be God. That is what I also think. And when you study about the philosophy or the how this universe has come up after Big Bang.
Now, please tell us about.
No. Yeah. See, I'm not a very good learner of this. Not to say theoretical physics or that is
theoretical physics. That is from your physics. You said you are not a very good learner of theoretical physics.
Yeah.
You have said that you are a student of physics.
Yeah, see, physics is a very vast subject.
So what is theoretical physics?
Not theoretical. Theoretical physics is something which can be everywhere. In material science also there can be theory.
No, when you said you are not a very good
high energy physics, you can say, or you can say astrophysics.
Okay.
Or particle physics.
Okay.
So if I talk about those things, I'm not very good. I don't keep, but yeah, if you ask me about because universe, or I think you have asked me about black hole also.
Yeah, you didn't answer me.
Yeah, so black hole, if I try to make you understand, आप एक बड़ा सा you take a rubber sheet.
Taken.
You catch two corners, I catch two corners.
Okay, yeah, okay.
Like this. So you are expanding the rubber sheet.
It's an
You put a very
elastic है ना?
elastic है. You put a this is a space-time what we are talking about. Our space-time curvature that we are talking about.
अच्छा, ये स्पेस टाइम है.
हाँ. Now you put a very high ज़्यादा मास वाला एक बॉडी को बॉल को you put in between.
मतलब ये कप को सपोज
एकदम बीच तो क्या होगा? What will observe?
इलास्टिक है तो नीचे
जाएगा ऐसा ना. So you're creating a space in the space time.
स्पेस टाइम तो ये हम पकड़ा.
हाँ, ये अपना space time है. Sorry.
उसमें हमने void क्रिएट किया ना.
Void नहीं. You're creating a what to say?
What have we created? Is it not a whole now?
It's not a whole exactly. You are what I can say. You created a portion, or you can say one part of a space-time graph, such that a very high mass of body has
fallen and is extending it,
and it is creating an anomaly, or you can say
it is definitely creating an
anomaly in the space-time.
Yeah.
And what it is doing is that this portion will be like a very high gravity area, because a very high mass particle has collapsed. You can say a very big sun from another solar system, which have very high mass, it has died and it has collapsed, and now it has created a black hole in that portion of this time.
तो that hole को black क्योंकि hole तो नहीं,
black in the sense कि
circle तो हुआ है, circular एक space तो create हुआ है.
हाँ, उसमें इतना high gravity will be, because the mass is very high, the gravity will be very high in area. So if the portion just around the dip, we call it as event horizon.
Okay, taken.
And the dip we call it as center of the dip, we call it as singularity.
Okay.
So whatever mass comes in contact with the event horizon, it will get trapped into the black hole. Let it be light. If the gravity is very high, it can be light also. So those kind of
you're saying that
currents.
You're saying that the light also will be
trapped. It can be trapped.
It was sucked in.
Yeah, it can be trapped.
Okay.
It can be trapped. And light also bends around the event horizon.
Explain the phenomenon.
It's due to gravity. Light bends due to gravity, basically. Which is explained in the sense that it can be explained in terms of observation of solar eclipses. So it's a very old experiment. If I can give you one idea about one movie that has come up long back, Eddington and Einstein. You can see how Eddington's experimental observation of solar eclipses has shown that light bends due to gravity.
Okay.
So he has done some experiments in solar eclipse, saw the nearby stars from our sun. When eclipse occur, there is a how the path is blocked and how the light from the star has been captured in his camera, whatever equipment he has in those times. So he studied did some experiment, and he basically it is like it helped Einstein general theory of relativity to establish what it has said. Basically, that line bends due to gravity.
So when we are speaking about light, it is not known, but it is almost theoretically theorized that light at times behave like particle, at times it behaves like.
That is the basic point of mechanics, basically.
So when you are saying that light bends, I could assume that the light is bending when it is behaving like a wave, and when the light diffracts or refracts,
it can behave like a particle.
It's behave like a particle because the deflection is straight up. Right. It is not bending. Not bending and not curvature bending.
No, it's not. You can say.
So this entire universe is quite interesting, right, sir? The phenomenon is quite interesting.
Yeah, actually, if you dive deep into all these phenomena, आप बाबा बन जाएगा.
ना मतलब आप सोचिए अभी तक हमने जो बात किया है या जो भी हमने डिस्कवरी हुआ है उसका बारे में हमने टेबल पे बात किया है. These are all based on the tools that is available for humankind to understand the phenomenon.
Yes.
Tomorrow if we get high definition, better definition tools, तो हमारा रियलिटी बदल जाएगा.
फिजिक्स वही है सर. आप एक बात समझिए, जैसे हम लोग 10 में कुछ पढ़ते हैं कि दिस हैपेंस ड्यू टू दिस इज करेक्ट,
Which is correct.
विच इज करेक्ट. 11 में जाएगा, बोलेगा ये होता है ना, ये अभी एक्चुअली ये इसको होने के लिए इसको और एक कंडीशन चाहिए. दो ऑब्जेक्ट है, हाई मास एंड लो मास, दोनों अलग अलग है. फेदर इन ए बुक, you leave it, it will fall down in the same time. Everybody knows,
Yeah.
right? But there has to be vacuum.
Yeah, that's correct. There has to be vacuum.
So यही चीजें हैं.
Yeah.
So you go on studying, you'll go on studying exceptions, you'll go on studying
We are getting closer to the truth.
exact.
ये सत्य का ही पाथ में चल रहा है.
And you never know, a new theory will come up and say all these things are wrong.
Yeah. And so as you've said, when Sir Newton stopped somewhere, वो बोला कि इसके आगे
तो भगवान है.
उसके आगे भगवान
It's
है.
written.
ठीक है सर. इन दैट डिवाइन नोट खत्म करते हैं बात. लंबा भी हो गया है. फिर मिलेंगे.
Thank you.
नेक्स्ट टाइम मिलेंगे तो लेट्स से और एक फिजिक्स कॉन्सेप्ट का एक डीपर जगह पे जंप करूंगा. I'll bring a topic and let's speak about it.
Although whatever I have talked, it's not my domain of research also.
Yours is material science.
Yeah, mine is electronics and material science basically. But actually, whenever we talk about physics, we always dive into these topics. You cannot escape.
फाइन सर. एक बार मेरे ऑडियंस को फिजिक्स पढ़ने के लिए बोल दीजिए.
हाँ, फिजिक्स इज लाइक, फिजिक्स पढ़ने के लिए मैं क्यों बोलूँगा, इफ यू आर इंटरेस्टेड इन knowing how this universe works, if you are interested in mathematics, if you are interested in asking questions, you should learn physics.
थैंक यू सर.